Welcome in. So, we're in a virtual world, and I have a couple of programming games that I've had for a while. I've played a few of them, not all of them, but I thought I'd take a look at some of them, the ones I haven't played. Another one that I have is Gray Hack. And then another one that has to do with AI logic. But this one's called Joy of Programming. And I believe it uses Python, so we'll be right at home. If you don't know Python, then get ready. We're about to learn it. A very useful skill to have. Very interesting. Stop programming. E. Interesting. Just looking around, it's a fairly normal scene here. I got a whiteboard, man. I miss my whiteboard. Here's the Steam game here, and there's nothing else I can really click. It'd be cool if I can interact with the Steam page through here, but hey, let's start it off. Uh-huh. I hope the music's not copyright. I really do hope so. Anyway, I might even change it if it's too repetitive. I'll just do my playlist. But here we are. We can play scenarios, huh? Let's see some. Learn how to control automate sim environments with Python. Fair. Conveyor belts. If condition selections. Hey, let's do it, man. Let's go through the basics. I might even update the stream. Learning programming through games. Because honestly, man, that seems like what we're doing over here. So, well, you can ask the assistant. Oh, okay, so you got an assistant. Cool. Let me update this. Ow, cat. Ow. Let's see, a little quick update. Ooh. Welcome. Alright. Pan the camera with WASD. Cool. Click on the box. Cool. So we got a delivery container. So this is its objects created from a class that we don't see. We don't know what it is right now. But we do have something called underscore entity delivery container 0. So this is that particular created object. We've got delivers all objects currently inside a delivery box. Door must be closed for this to work. Okay, interesting. Okay, so there's conditions, right? If door closed, there it is. Container dot get is door closed. Container dot deliver. Okay. Container equals delivery container. Let me upgrade the music. It's a little low now. Could use a little background. There we go. Okay, and then we have two functions or methods because it's inside of a class. Always remember, functions are outside of classes, but when we create a class that contains a bunch of variables, attributes, I believe, attributes and functions, which are methods, they are owned by that particular class. We haven't even really touched on any of that in any of my office hour streams. But I did mention that it is one of the first 15% of all languages. So I guess we're going into objects now. So container equals delivery container dot first. If container get num inside greater than 0, container close door. All right. What's our task right now? Open the delivery's door. I guess I'm just clicking it to open it. Interesting, interesting. Click the conveyor belt. Target speed. Let's do 2. Set target speed. Cool. So we're basically throwing a integer into a function that will modify the speed of the conveyor belt. Yeah, I can go for higher. I wonder if I can just like hack it and go for like 1,000. Close the door. Simple so far. Oh, right. I can do this now. Nice, nice, nice. Deliver the box. Close door, deliver. Great. Okay, so where is my Python? Now, this is the very basic tutorial, so we're essentially learning the mechanics of the game. Because it's like the next thing on top, right? We have Python in the background, and then we have this game interface that's going to let us interact with the programming language. It looks like it's just clicks for now, but let's keep going. I like it though. It's kind of one of those puzzle games, right? It seems like simple for now, but let's see. Open the code window for this tutorial. There we are. Ooh, yes, baby. Give me that Python. All right. Read the code and try to see that it will repeat the steps you executed manually. So the first case was the manual execution by clicking. Now we got to execute those same steps using code. All right. So from importing PyJob, not sure what that is, but looks like, let's see, Joy of Programming module. So always remember that when you're importing the 85%. The first 15% of all programming is if statements, variables, functions, classes, while, for, try, catch, all those kind of like just syntax concepts that you learn. The other 85 is like, what are you programming for? That 85% is going to be based on the imports you include in your project. So in this case, we're in the game called Joy of Programming. So there's Py Joy of Programming. So we're importing from Py Joy of Programming. We're importing everything. This is what the asterisk is as a wildcard. Nothing specific. Everything that's inside, we're taking. All right. Simulated environment. I'm guessing that's what it's called. Sim environment class to connect to the current level. Very cool to see. The sim environment, in our case, it's this level that exists. So everything we have in this level, let me go ahead and do this. Everything we see, whether it's like interactable or not, is generated and saved also into a variable. So this guy here in a variable, or in the class that we just created an object. Well, okay, they gave us that object. We haven't done anything to create it. They created it, and now we're like basically piggybacking on it by using sim environment. We're connecting to this object, which was created by the game, and we're connecting to it so we can interact with those particular objects. This is important for game development because this is how you will be interacting with code and 3D objects. You will have ways to connect to those objects using code, but you have to know like Blender. Well, Blender is more to 3D, so like Unity, Unreal Engine, they will have also names for the objects in the world that you're working with. But in our case, we have one kind of encompassing box called sim environment. Inside that box is this delivery cage, this conveyor belt. So, variable pointing to the conveyor belt. So there it is. Conveyor belt that find entity conveyor belt 0. This is also important. When you have a lot of objects in a world, oops, don't want to change that. You're going to have specific functions or methods, or in this case, an object with a find method. You're going to have this object that is specifically built for conveyor belts. You could have 100 conveyor belts in here, naming them like 0 through 100. And your specific case is, I want to pick a specific one, so I will find that and then grab that through this naming convention. This naming convention, this identification specifically. Also in Roblox. If you program in Roblox, this should be very like find child, find parents, parrot, like a pirate. You'll find that these essential tools will differ in name, but they serve the same purpose. And in our world here, we are finding a conveyor belt with the ID, identification. This also works for HTML. when you're trying to find any object or HTML tag in your document, you're going to be looking for either IDs, which are in HTML unique. Only one thing can have an ID of a specific type, or a class. A class which can get also confused with programming classes versus XML type classes. But the big difference is a class in an HTML document is just another name, a way for us to reference that specific tag. The only difference between an ID in HTML and a class in HTML is that, well, IDs are unique. There can only be one, but classes you can have as many as you'd like 100 of them or 1,000. You can actually get a bunch of items, put them in an array of classes, and you can just find that specific class and then put all of those tags in an array so you can organize everything. So, a little tangent, but I like to kind of speak as I go, speak from thought. None of this is planned, so we're just kind of diving into this, and I'm babbling about programming in general. But it's a good amount of skills to actually absorb here. Oh, we kind of moved. All right, so we're taking this conveyor belt specific object that has to do with conveyor belts. We're using an internal function called the method to find a specific conveyor belt, which if we click here, there's the name of it, right? Entity conveyor belt 0. So we're looking for that in our world, and we're saving it to a variable. Here's just the magic of variables. Variables make us lazy, which is great because honestly, that's the key that we'd like to go for. Now, there's nothing stopping me from copying this, and every time I see conv, like this conveyor, conv, and just using that long code instead of conv. So I can use conveyor belt find entity conveyor belt 0 and then dot set target speed. I can do that. But variables make things convenient. Instead of having to retype that whole thing over and over again, I can literally just put conv every time I want to talk about this particular conveyor belt. I don't have to keep finding it. In fact, it's actually better because on the processing side, you're not prompting or you're not processing your program to constantly be running a find function, right? Once you find it, all that process is done and you save that into the conveyor. That's it. So you kind of save yourself processing time as well by actually using this variable, because now the variable contains that specific entity conveyor belt 0. Instead of having to search for it every single time you need it. Like here, we have the creation of the variable. That's where the equal sign comes in. Then we have the usage of that variable, conveyor or conv dot set underscore target underscore speed. So that's a specific function that we saw right here, right? This is that set target speed function that we used before. We modified it before with the little bar over here. I don't know if I can move that window, but not really. But now we can actually modify it using an input integer, so 1.5. Then we have a container. I'm guessing this is a container. True. Delivery container. This delivery container now will have, okay, we're basically doing the same thing, but this time we're saving this delivery container. We're finding its identity, which is entity delivery container 0. And we're throwing it in this container. Cool. So now we have conveyor saved in the variable conv and container saved in the variable container, just by finding them through our particular find method. Open the delivery door, wait a few seconds for the bearer to arrive. So notice before we did it manually, we had to click one, activate, click another, activate, click one, the other one, activate, activate. Here, we're going to be doing this like automatically. We're going to be doing this in repetitive motion. We're just giving the computer instructions. In this case, it's only once, unfortunately. We can create while loops. So we're probably going to go into a huge set of, well, things we have to like push through this conveyor belt. Right now, it's only one object, right? So we take the container. Instead of me clicking the open door button, we're going to use that through an open door function. That's really cool. I really like how this is working out. I really like this the way this game is organized, and it's nice and chill. Then we have to sleep. What does that mean? In Python, that just means stop for a moment, right? We have to wait for that container or for the little barrel over here to move through the conveyor belt. This can be variable and it can change, so sometimes we can use a variable in here to change it as well. However, I guess after 18 seconds, it's an estimation, right? After 18 seconds, the barrel should have arrived. I can also speed up the conveyor belt speed and reduce the sleep amount, but I'm not going to change anything yet. We're simply watching and seeing how this is going to work itself out. So after it arrives, we container that closed door function or method, and then wait until it's completely shut. Takes about 7 seconds. Really? I don't think it took that long. And then finally deliver the barrel inside a container. Cool. So that's already created for us. So that's really nice that we actually just straight up being given this code and I can run. Ah, look at that. It's actually running Python in the background. That's sick. That's so cool. My security software is picking up on extra scripts that are running, so that's really cool. It's actually literally, it's not just some simulation. Hold on. I think I have to patch into my security a little further. That's so cool. It's actually using like straight up. No, it's not. Straight up Python. I might have broken the first. Yeah, it looks fine. So because that happened, I may have busted this up a little bit. Because the game probably doesn't expect... Okay, it stopped. Let's redo it. Oh, come on, just treat it as like an allowed application. Okay. Okay, cool. At least I can stop this script running process, because sometimes when my antivirus is running or a firewall and everything, it just kind of hangs it. Are you going to keep doing this? You really are. You really, really are. Oh, there we go. Yeah, let's go. Let's go. All this running through code. No buttons clicked. This, my friends, is why we love programming. This literally will happen within an assembly line at a factory. And just get ready for... Nice. That's way less than 7 seconds. So now we're waiting. Okay, there we go. This will basically be the future. There will not be many factory workers. There will not be people in the assembly line. You will be doing this to program robots to actually do the job for you. You ever heard of Flippy? I think it was like a McDonald's arm that flips burgers for them. Yes, you will be programming Flippy. So I suggest you really, really patch in, lock in, and let's learn more, because this is gonna be the future. What? Okay. In most levels, there's a hidden briefcase containing interesting information. Hey, now you tell me. Alright. What? Infamous Hello World program in Python. Prints Hello World onto the screen. Yeah, that's it. Sorry. Very basic. This is actually how we can understand the very basics of a language. There's your function. It's a block of code that exists somewhere in the computer, already created for you. We invoke these round brackets to create an input. And then we can input all kinds of stuff, but in this case, it's just a string. We can do integers like we did with the 1.5, but we're just carrying over some information into the print function. The function itself determines what it does with it, based on the code that it's basically created on. Some functions can accept a bunch of different inputs. Strings, integers, decimals. Cool. Happy coding. Watch or skip video. All right. All right, cool. So nothing happens really here. That was a cool little intro. But yes, okay. So the hello world infamous statement. Why do we do hello world? Why is this such a very common, well, I guess code program. I mean, I guess it's a program because it's just like one line, but loosely called a useful program. When we dive into a new language, this helps us with a few ideas. First, how is it that we have to set up a basic project for this new language? Well, it looks like we have to always use pyjob import asterisk, and we should connect to the sim environment space. Then we can print out or use the Python keyword for print, a function that will, again, functions are like mathematics, right? Remember variables and functions? A variable is a single thing, so we have a variable here. It's called hello world. It is a string. Technically, it's not saved to a variable. This is a saved variable. We give it a name, like conveyor, right? conv. This is just a literal. It's just a string that exists in space, not saved to a variable. But if we were to, for the argument, consider this a variable, that's the type that we can normally do. Numbers, strings, booleans, integers, decimals, all kinds of different, and there's like a data science, computer science sort of concept behind how large each one of those variable types are. We don't have to dive into that though. But there are a couple of bits depending on the language you're using. If you're in C++, you will know, or at least have seen the sizes. So it tells us how do we create a string, how do the functions work, because most languages will be basically the same. There wouldn't be too crazy of a divergence from the way that the functions specifically work. And hold on, what's up with my... Is this really how it looks right now? Hold on. It's a little buggy. Why is that doing that? Oh, my video. Why is... Oh, you know what? Maybe because there's a signal in between. Hold on. Maybe because I'm exporting the signal too? Weird. Is that always done that? Hold on. Is this just the game doing its thing? Wow, the game is projecting some weird signals. Hold on, is that how it looks on stream? That's not good. It's a very annoying looking stream. I gotta probably mess with the video quality or video aspects of it. It could be just my OBS acting weird. I just want to double check real quick what stream looks like, because I'm seeing some artifacts. Yeah, no, it's doing it. It's doing artifacts. Okay, so let me adjust some of the graphics. Hold on. Is it a VSync thing? Quality, ultra, full screen. What if I do full screen? Is it gone? No. Hold on, no. Not yet. I don't know yet. The stream's a little laggy, so give me a second to kind of judge this out real quick. Let's see. Okay. Oh, I forgot to go back to this. It might have worked. I think it worked. And now those lines and those red artifacts shouldn't be there. That's a very odd. It's a game by game thing. Mm. Also, for some reason, it's out of bounds here. No, it's... Still kind of doing it. Oh, that's disappointing. Why do these? What if I change resolution? Why you do? Well, it's not too crazy, like, in the way, but I hate the fact that it's doing it. What's low gonna be like? Nothing changed. Oh, it's gotta be something based on the data transfer. Ah, can I replug in my HDMI? All right, this is the last thing. Last check I'll do. Like, it could be just noise in the cable, but it doesn't do it for anything else. It's weird that it's visible here, you know? Ah, okay. It was the HDMI. All right. Well, there we go. Now it's fixed. Good enough. Good enough. I'm just double checking on stream one more time because I see it in my OBS, but I want to make sure it's also good on stream and perfect. Okay. All right. So I didn't have to mess with any of the settings. So let me go back and raise quality. Cool. And let's do windowed. I prefer windowed. Let's go back to our resolution. This should be fine now. Awesome. Okay, so there was a bit of a fluke there with the graphics. I guess my cable was a little dirty or something. Anyway, back to the hello world. This is just how we test out, dip our toes in the water to see how a programming language will work. And in this case, Python. So we use print hello world. We sleep for 1 second, not sure why, but I guess we can do that, sure. Then we create again a conveyor belt variable, save it there, and then set target speed to 0. Well, what's the target speed right now? Still 0. Sure. Again, nothing useful here. This is simply going to show us the mechanics of the environment we're in. Really not even just a language like Python. How do you use Python? Well, we have a couple of annotations. But again, we use the hello world concept to test out how a new developing environment works. And in this case, we're inside of this joy of programming environment. So we're seeing how we're going to grab conveyor belts, how to set target speeds, or how to access functions inside, and so on. So we are learning the type and the usage of the current environment, which in the end, I can basically take a look here. Conveyor belt, I have to remember that there is a find function inside of conveyor belt, and then I have to use this identity here to find the specific item. So we're basically given hints now, but we potentially will not have these hints later. Oh no, really? We're gonna have to be doing this all the time? I guess every single script is unique, so it's gonna be going through all of them. I have to like enter it into a... Okay, there it is. I remember the answer this time. PyJob connection established. Oh, there's our terminal, our log output. So this is always a case where most languages will give you a place you can take a look at what's happening. Print will print to a specific place, and that's our log, or our terminal, or our console in JavaScript. But it's great to always know where your outputs are going, so you can use print in our case very often to see what's inside of variables and use that as a debugging technique. So PyJob connection established. I'm assuming this is from the line 3, or when we do sim environment, line 4.connect, that tells us connection established. And then hello world comes up later, and we're done with the next one. Okay, cool. So we did some setting configurations. What else? What else? Change the code to set the conveyor target speed to greater than 0. Okay, so we're just kind of fulfilling some aspects here. Okay, so stop first. Can't edit when it's running. Let's do 2, and then run it. Wait for the barrel to drop on the floor. So there we go. Conveyor belt entity tween target float is another word for, well, decimal type numbers. Or was it negatives? No, integers were also negative. Finish. Cool. Alright, let's get to the nitty gritty. I want to do some more complicated stuff. There we go. What's going on? Indentation in Python is used to scope code blocks. A very complicated word for basically saying organizing code by levels. For example, all code that should be executed if some condition is true must be indented under the corresponding if clause. Cool. We're going to probably take a look at this concept here. Ooh, that's interesting. For loops! Yes, here we go. Let's say you want to sum up numbers 1 through 99. And using Gab, summation is not allowed. There's a box. Hello, box. The above code is a bad idea. Lots of typing, error-prone, and not reusable. This is a variable equals all the additions, right? So what we do is we create a variable s equals 0. We go through a loop of ranged values. And for each loop, we add the previous value to the next. I is going to start at 0, go up to 100. There's the indentation happening for the code block being specific to this for loop. Why is this? Why are you dropping so many boxes? I haven't started yet. Wait. There it is. I changes through the loop. It's a count. It's basically counting. As I is counting, we're also adding that I to the S or whatever the previous S was. So notice how it keeps going based on S consistently saving the previous value, adding the new value to itself, and saving back into S. Uh-oh. Is that supposed to happen? Is there gonna be more? Okay, great. Thanks for letting me know, but oh, okay. Well, let's move that speed a little bit. Let's do this manually real quick. Okay. Alright, so use speed up, slow down, or pause, reset simulation. Where's that? Oh, down here. Okay. So let's pause this real quick because we need to really program this before we get anywhere. We have this conveyor belt running based on our manual adjustment. So I'm going to put that back to 0. But we basically want to turn on all of these. Let's take a look at the details. This is conveyor belt 5. This is 7. This is 8. This is 2. This is 1. This is 0. This is really badly organized. This is 3. This is 6. And 4. So we basically have 1 through 7. It looks like we have 1 through 7, right? 5, 7, 8. 1 through 8. 2, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. Man, this is really poorly organized, unfortunately. But that's fine. We know we have 8 conveyor belts. So how do we turn each one on as we go through the loop? Basically, we can go, like, imagine having to actually manually run around and turn all of these on each time you're starting this process. Oh, okay, there we go. Okay, well, I was gonna do it myself, but thanks for that. Okay, cool. So, in this case, we have a new function. Again, we're always starting with sim environment, connect, and from PyJob import all of it, everything inside. We can't see what's inside, but we can assume that some things are coming from inside, like sim environment, conveyor belt, and so on. So all conveyor belts, this is the variable name that we're going to save our conveyor belts in. This time we have a new function. It's called find all. Notice there's no specific name in there. That's specific because we're not caring about any name. We're just going to go ahead and grab all of them. What I was going to do is, since I know I have 8 of them, I would have made a loop go through 8 from 0 to 8. and turn on each one manually using their entity. And I might still do that just for the example's sake, because you can code in all kinds of different ways. That was my initial thought, but this is a much better thought because now it doesn't matter how many we have, it's going to find all. We could have 5, 10, 15, 100, 1,000. It's still going to find all. So what we need to do now is consider that as we're going through this for loop, can I zoom into the code? Oh yeah, let's go. As we're going through the for loop, a loop that continuously goes over and over and over, we're going to be using the conv variable that's going to contain each of these conveyor belts, particularly in order, I think. We're not sure yet, but we'll find out. And that order in itself will have conv change. Just like that for loop earlier, when we saw the video, it basically ran and ran and ran over and over, increasing integer I. If you missed it, rewind a little bit, see what it was in the video that we just started off this level with. Integer I kept going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way to 99. That's important because that's what a for loop should do. It will continuously increase the value over and over. Here, we're not increasing a integer value, but we're navigating through all conveyors, all conveyor belts. Given that, that's what's given from the find all space. This should give us every single conveyor in something called an array. We don't know what that is yet, but this is at least a simplified version of showing us this. And this now holds like a list of arrays. An array, a dictionary, every single language calls it differently. But all of the conveyor belts are saved in here. So when we're looping conv in all conveyors, we're simply saying that this is going to change based on which conveyor belt we're focusing on. For the very first loop, it'll be the very first conveyor on the list inside of all conveyors variable. It doesn't highlight very well. Is it highlighting well? Every time I try to highlight something, it just kind of bugs out. Okay, it's better. Anyway. And then when we go to the next loop, it'll change to the next conveyor. Conveyor 2. Or in fact, we start from 0, so it'll be conveyor 0, conveyor 1, conveyor 2, conveyor 3. We saw we have 7, so we have 8, but computers start counting at 0, so we count 0 as the 1. A little bit of a trippy idea there. I mentioned this before. This is where the off by 1 errors tend to happen with new programmers. When we still, as a human being, consider, hey, we count at starting at 1, but computers aren't like that. They count at 0 specifically. All right. Let me just do something real quick. It's a nice instrument. So, I'm just trying to adjust here. Feel free to ask questions, by the way. If you do have any questions at all, I'll be happy to answer. I'll just have to take that moment to do so. All right, so conveyor in all conveyors. So how do we access? We do the exact same thing we did last time, except this time we're going to consider that this conveyor is going to change for us. Also, very cool. Look at that. Look at that. We are kind of given all of them. There's the ones we just counted. 1, or starting at 0, right? 0 is right there. 1, 2, 3, 4, and so forth. I really don't like how they organize this, but this is literally the developer organizing this in a weird order. I would have done like 1, 2, 3, 4, normal human being numbering, but hey. So the last time we accessed that information, we did conv dot, there it is, set target speed, and this was the variable we click on here, right? Set target speed. So we're going to type that in, set target speed and 2, I believe. So what this is going to do, we're going to go through each one, and this is probably going to happen in such a quick space. Why is it? Oh, I'm stuck on one of the conveyors. Oh, yeah, right. Oh, it's going to happen so quick that it's basically going to turn all of them on. We won't be able to see them activating one at a time. So I kind of want to slow it down. Let's do a sleep just for the fun of it. And we're going to watch each one of these conveyors turn on every 2 seconds. Missing perks, your code has keywords. You have not yet unlocked. What do you mean? I haven't unlocked this keyword. Use the speed up. Use speed up. Reset the simulation. Oh, I have to follow these things. Hold on, perks. Can I? Oh, no kidding. I have to actually like unlock stuff. Ha 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 ha. That's cute. Alright, great. Let's just do it all. How many do I need? There we go. That's adorable. Alright, so now I can use... Wow, I never thought I'd be unlocking for loops. Oh, here we go again. I guess I gotta do it once per level. Ah. Okay, so, yep, there it is. Every 2 seconds, a conveyor starts. Right. So this is how we can kind of control the sequence. There it is. I think one of these is gonna go. Oh, there you go. There you go. Of course, we'd probably want all of them to start off right away. That's chaos. That's not what you want your manager seeing. That's how you get fired. But because we used the sleep, we could see visually each one of those conveyor belts turning on one by one. Otherwise, if I didn't use sleep, it would have basically done all of them at once, and it's a little bit more confusing when we think of it that way. So I like to slow down this processing because again, a computer thinks like billions of seconds, billions of times a second. Try to time control. Double the speed. Reset simulation. Oh, can I? Oh, reset right here. Okay, cool. All right. So it just wanted me to play with those. Burn 5 boxes. Okay, that's the goal. All right, so let's do that again, right? This time, I'm not going to use sleep. And this is going to essentially start all of them at the exact same time without any delay. There it is. Computers are just that fast. They don't care. They think so fast that they're basically going to... You know what? What's the highest I can go? Gimme 4. Gimme 10. Go beyond the limits. I don't think you can... Oh, it's set to 5. I guess the fastest speed is 5. I wonder if I can force it to go faster. Do a couple of hacks. And then... That's a pretty cool... I like it. A very cool little game. Speeding up the process here. Code running. Ooh. Explosions. Okay, that's interesting. Nice. Alright, let's get this level done. Oh, my foot's falling asleep. Kitty. Oh, my little kitty cat. You're making my foot fall asleep. Hold on. Oh. Oh, okay, there. Next one. Let's go. People come and go, man. I've had people come in. But I'm also recording this for the general sense of having it on here. You know, a lot of people watch it after the stream. Not everyone, like, is awake right now. So, depends on where you are in the world. But hey, it'll be on the internet for you to watch anytime. That's the whole point. If conditions. Alright, cool. So this is the case for activating certain situations. Import random. Okay, that's another little function that we can grab from Python, and it basically creates a random number for us. It's almost like flipping a coin. We set that random value into the variable A. And then we test A to see whether it's greater than or less than 0.5, which would be your typical odds of flipping a coin. We can also emulate dice if we think of a 6-sided die, and we can adjust that value. But in this case, we're only doing 0.5 since we are essentially doing a print heads, print tails, a simulation of flipping a coin. If you ever wanted to have a coin flipping program that basically like, hey, should I do this? Heads or tails? There it is. It's not that crazy. So the randomness keeps happening, and in reality, it's not really random. Randomness is more of a time-based sequence. A computer doesn't know how to be random, so it uses the current date to generate that specific value. So you can technically go back in time and still get the same value, which is how you hack stuff, by the way. Being able to figure out when a, let's say, password was encrypted, go back to that exact hour, minute, second, and encrypt with the same value, you will essentially decrypt the password. This is only one out of a million different ways, right? With this rangefinder, entity rangefinder, RFID tag box, distance 6.182634. Oh, it's the oh, nice. It's actually detecting the distance between the box and that specific location. Okay, cool. Write some Python code to move 5 barrels to the container on the right, move 5 boxes to the container on the left. Interesting. You can ask the assistant for help. Okay, okay. Entity rangefinder is this new device that we are currently looking at. And we need to move barrel. We are sorting barrels and boxes on each side. Got it. Barrel to the right, box to the left. Got it. So then this identifier is going to tell us what we're looking at. So right now we got to identify RFID tag box. This is where it gets complex, right? We got to grab our scanner, get RFID tag, which is going to tell us what that thing is. If it's a box, we do one thing. If it's a barrel, we do another. Sounds cool. Good. Okay. So here's a game loop. What? Hold up. What? Why was there a door? There were hidden speakers. Oh, dude, I can set the speaker volume on this. No kidding. All right, cool. I didn't even know there were speakers up here. That's pretty cool. I feel like someone's behind me. Oh, there's the suitcase. What? Okay. New fact sheet collected. Well, what is this? Hash tables, also called hash map or dictionary. Foundation of data structure that has a surprising and unique property. No matter how many elements are in the hash table, finding and retrieving a particular element by its key always takes constant time. So this is very computer science related, adjusting and figuring out how much a particular action takes in a computer through the programming aspects of things. Looking for and searching through values in a hash table, for instance, or dictionaries, arrays, whatever you'd like to call them. All right, we found a cool little Easter egg here. Very cool. So let's get to the programming part, yeah? So let's read our code that we start with. First, simple, same as always. PyJop import, everything, sim environment connect. Then we grab the only conveyor belt in the system. All right. Now this conveyor belt target speed, it has a left and a right. So if I really look at this, I can set it as a negative number and a positive number. This is important. This will adjust the direction. Important situation in programming. especially in game development. Positives and negatives in a virtual environment will deduct the direction in which something is moving, looking, or interacting. So we got a scanner. Cool. The scanner is going to tell us what kind of box or what kind of object we're looking at. So now we have to essentially add your code within this loop. The sim environment run main is just a way for us to have a game loop. You open up your, or you turn on your PlayStation, you start your game, call it Call of Duty, and there's a game loop that runs forever until you press exit. This is the same thing. Until you go to back, exit game, this game loop happens and then the background runs and your menu is shown and then you can navigate through that game loop, and then when you press exit, you leave the game loop. So in this case, we have that. Here, we're taking our scanner. Again, the scanner is this little guy down here, and it's identifying a box at a certain distance. So we need to get a tag on the box. Then we have to test that tag. If tag is equal to box, which is not capital, right? Let's see. It is capital. Capitals are important. So change that B to a capital B. Then what we want this conveyor to do, actually, we already have the conveyor. Okay, so it's conv is the variable for the conveyor. So do conv dot set target speed. And boxes are to the left, so I got to use a negative value. So -5. I'll do it as quickly as possible. Then we check for the barrel situation, right? I'm guessing it's also going to be capital. And if we have a barrel, we're going to set the target speed +5 to go to the right. And that's it. That's it. We just added a couple of lines, really 4 lines. And now this is going to sort our barrels and boxes based on the scanner identifying what we're looking at. And I'm probably going to have to, yes I am, allowed. I gotta like put this in exceptions or something. Let's try that again. So there's the running. It identifies a barrel. Or a box. Okay, identified a box. It's still moving. Do I have to program? Okay, there's a barrel. No! Ah! That's so slow. Ah, that's so funny. It does take a moment to adjust. There's a case where we can adjust this, the speed also when the distance gets to a certain level to make it a little smoother. But look how it's wobbly. That's funny. It's like it almost makes it to one side and then, just kidding, over there. I think I want to adjust that, optimize it a little bit. So this is how we sort information in programming. If and else loops. Thank you for joining. Leave any questions if you'd like in the comments. I'll be happy to answer. Just waiting on this. Really, I can speed it up, right? Yeah, there we go. Let's go for it. If conditional is complete. I'm waiting for the complicated puzzles. Next. Okay, click. I really need to add this as an exception. Selection. Dark. Maybe my... Hello? Reset. Well, looks like my antivirus probably broke this. Oh, I have multiple script spaces. Cool. Anyway, let's unlock some perks. There's a function. Nice. Try accept block. Super. But I feel like potentially I have gotten to a point where my antivirus really broke my interactive abilities. So I gotta stop it here. It was fun. I'm probably gonna play some uh Project Wingman, fly some airplanes a little bit. But I hope you enjoy this. This is a good little in look in what's the word I'm looking for? I'm a mathematician, not an English speaker or English major. Uh, insight. Good insight into programming on the manual case scenario. And we'll probably do some more because this is pretty cool. I do enjoy it. But we have done code in the past, right? My channel is essentially on this case where I'm teaching how to do code in basics to advanced forms. Um, and if you do enjoy this content, if you found this helpful visually, I will do more. I'm not a professional streamer. I'm just some dude. I'm a teacher. I'm a teacher. I teach students mathematics and programming. So excuse me for being human sometimes. But if you want to learn more, subscribe, like, and hit the notification for my office hours where I take live questions. If anyone has any questions at all, I answer them. I have no problem interacting with anyone online, asking questions and teaching. That's just the essence of my existence is teaching. So thank you for joining. I hope you enjoyed and learned something today. And remember, learn something every day. I don't feel fulfilled if I take one day without learning something. This is just the human way. We always learn new things, and we should strive to better ourselves one new thing at a time or at a day. So